All right, so one more thing that we have here, and this is transformations and inequalities. So we're going to mix all of our different transformations up, and now we're going to add this inequality back in. Okay, so what we did earlier when we solved inequalities is we said that we could have a union or an and. So we could have an and or an or. And we said that if we had if it was greater, we would say greater. And if it was less than, we would say less than. Okay, so we talked about this, but now we're going to graph this. And to me, I think it makes more sense to do the graph and do the inequality and then draw our region that makes sense. So I have an absolute value function, so I know I'm going to have a v, and I have a vertex here that's 2, -1. So I go to 2, -1, and I have a value of 1. So if I draw my line, it's going to look like this. And if I go this direction, hold on, let me just make sure this line looks good. It's going to look like this. Okay, so that is my absolute value function. So now I'm going to go back to my equation, and it says over here, solve the inequality. So I just did this. This was in my blue right here. I graphed my inequality. And now what I'm going to do is I'm going to graph this part of my inequality. So remember, when we have a line, we say y equals 1. That would be the same as just saying 1 because we don't have any x's over here. We don't have a function. All we have is a line. So we have this line y equals 1, and 1 is coming from what's on this side of my inequality. So I'm going to go over here, and I'm going to draw this dashed line right here at 1. I can draw a solid line too, but I'm going to draw a dashed line because it doesn't really exist in my blue graph. Now, here is the key. This says what part of the absolute graph is below the horizontal line. Well, the reason we're looking for below is because this is a less than. If this was a greater than, we would want to know what was above. So below, because we have less than 1. Well, this is the part of my graph that's below. Right? So I'm going to have a region of answers again. And so my region of answers is going to be from 0, because remember, I'm looking for x values. So if I'm looking for x values, it's going to be from this value of 0 to this value of 4. So 0 and 4 are my two numbers. That is my x values for this interval. Now, because this is less than, that's like saying they're open circles at these 2 points. It's not included. So around this, I'm going to have parentheses. So if I have less than or greater than, I'm going to use parentheses. Less than equals, greater than or equals, I'm going to use brackets. So none of this has changed. All right, let's try another one. All right, so here's the next one. So what I know on this guy is that I have a quadratic, and then this quadratic is going to be greater than or equal to 5. All right, so I'm not even going to worry about the inequality. I'm just going to graph this. So right now I know I have a vertex at -1, 3. So -1, 3 is my vertex. And I'm going to have a slope, kind of a little fake slope. My first point here is going to be up 2. So I go over 1 and I go up 2. Right here. Over 1, up 2. Now this is super narrow, but this needs to look like a U because it's a quadratic. So I'm going to have this parabola, not too bad, parabola that looks like that. Okay? Now, here's where I'm at. This is what this part says right here. We're going to draw a horizontal line at y equals 5. So now I have this horizontal line right here at y equals 5. And it says what part of the graph is above, and it's above because this is saying greater than. So if I want the part of the graph that's above my dashed line, it's going to be this part and this part. So what I have here is I have, I'm going to go, remember these are x values. So I'm going to go from -infinity to this value here, and this value is -2. And then I'm going to start again here at 0, and I'm going to go to infinity. So I always have my parentheses, but what happens is because this is greater than or equal, these are included this time, so I'm going to use brackets. I have greater than or equal, so I have brackets. Okay? So this is really, if the hardest part of this is making sure that you graph your function correct. I think that's the hardest part. Okay, a couple more here. So I have this inequality, and I know this inequality is going to be a cubic. So I'm going to have a cubic, and my vertex here for my cubic is going to be 3, 2. So I go over here to 3, and I go up 2. All right, so my value here is 1, so I know I'm going to have these points here and here. So I'm just going to draw my graph. I'm going to have something that looks like that. Okay, so now I draw a horizontal line at y equals 3. So y equals 3, I have this horizontal line. It says what part of the graph is, this tells me, below. So what part of the graph is below? Well, this part of the graph is below. So what does that look like? That looks like negative infinity, because this is going to keep going until I get to this value, and this value here is at 4. So that's what's below. I go up here. This is less than or equal, so this has to be a bracket. All right, let's try this with these last two functions. So we had absolute value, we had a quadratic, we had a cubic. So now we're going to do a square root function. So square root function, where am I starting? I'm starting at -5, -3, right? So opposite here, so this is -5, -3. So if I come over here, -5, -3, this is my starting point. But now I have this A value. So this A value says that I've got an initial point that's going to be up 4. So I go over 1 and I go up 4. 1, 2, 3, 4. So this is going to be super steep. I'm going to have something that looks like this. Okay, so now I'm going to draw my horizontal line at y equals 1. And then this tells me that I want the value that's greater. The value that's greater is going to be this part of my graph. So my solution is going to be this value, so -4 to infinity. Now I'm using a bracket because, oh, that's so wrong, y'all. It's going to be parentheses -4. This is just greater than, so it needs to be a parenthesis. All right, last one. So I have a rational function. So my first asymptote happens, remember this is my vertical asymptote, it happens at 4. So I have this vertical asymptote right here. And my horizontal asymptote happens at 3. So it happens right here. And now I'm going to graph my 2 points. So I'm going to go to this quadrant and this quadrant because everything's positive. So here's what my graph looks like. Okay, now I want to know what happens when x is less than 4. So here is my line that I care about, and I want everything less than 4. So here's what I have. I have this is less than 4. And I have this part of it that's less than 4. So I still have 2 regions. And the reason why is because, remember, an asymptote means you get super, super close, but it can never equal this value of 4. So what happens is this yellow part that's below, the domain of this yellow part is going to be -infinity to 4 with a parenthesis because it can't equal 4. Now, I can't start at 4 again because I don't care about this part that's above. So from 4 to 5, this is above my inequality, right? This is above this value that I have right here, my dashed line. And I'm hoping you can see the colors on this because to me it makes a whole lot more sense. We're looking at this value, not this asymptote, which is my part of my function. So if I look at where it starts, it's going to start again right here at this point, and this point happens when my domain is 5. So it's going to start again at 5, and it's going to go to infinity. All right? So take your time, maybe use some colors, maybe highlight, and you'll have quite a bit of practice on this.